for the shortest remaining time first scheduling algorithm, um, we made it a bit different for this time. Since this is a preemptive scheduling algorithm, if something was added, so basically if a new process is added to the ready queue, then we sort the entire queue data structure, not just the ones added. Hence, whichever has the shortest remaining time first, that's gonna be on top of the queue. And then if queue dot size is greater than 0, whichever's on top will become the executing process. And if q dot peak, so the one on top of your queue data structure, and the previous executing process are not the same, and time executing is not equal to 0, meaning the current process was preempted, then it'll print out time passed minus time exec process 3.1, which is the index, and the current amount of time that's executing it. And it'll reset it back to 0. And the third condition is basically if time passed, if it's just it'll just assign it on what's on top of the queue to the current executing process. Time passed gets incremented. Again, it's outside because regardless of whether your queue data structure has any um, contains any element, your CPU time will still go on. And then it checks again if your queue has something. Your executing time increments. But now this is the one we made differently. Q dot peak of 1, which is basically your the required time to run is decremented so that we have a record of the remaining time. And then as usual, if it's now equal to 0, so it's no longer running, it's not supposed to run anymore, then we print out the details that's supposed to be printed out. Stop.